one more comparison of linear to exponential functions I want to go through with you so you can see how to write them and how they're the same but how they're different. So we have y equals mx plus b. Keep in mind that this is our slope, our rate of change, our change in y over our change in x. Some of you also like to do y2 minus y1 over x2 minus x1. Where our b is called our y-intercept. It is our initial value. It is also the value where x is 0. So we can take this information. We have an equation here, y equals 3x plus 2. If I gave you the x values, -2 through +2, we could plug those in for x to get our y. You could also use your calculator to do this, and we'll review that as well. So here you can see at the 0, this is our b value. Every time we are adding 3. If we didn't want to continue this pattern here, this would be 5, this would be 8, or this is our m. When we graph this, this is going to be linear. So I'm going to go up about 1, 2, 3, and make this my x-axis. About halfway is about here. Here's my y-axis. So I can graph these at -2, -4, 1, 2, 3. -4 would be about here. -1, -1, 0, 2. So again, you could also, if you didn't want to use the table up here, you could start at 2. You can count rise over run. And there would be your line. Okay, so again, you can see that this, because it is linear, that we're going to have a line. Our domain would be all real numbers when we did this. Okay. In like manner, if we came over here to exponential functions, this is laid out a times b to the x power, where a is our y-intercept, or our initial value. Okay, and this is our common ratio, or you'll also hear it called the factor of change. More likely we'll call it that common ratio because that's what we're used to. So again, if we were at -2 to +2, we could go through and lay this out. I am going to show you how to do this in the calculator, just to refresh you on how to use that graph to make it a table. I keep accidentally putting my x in place of my b value. So when you go to your calculator, we can go ahead and we can look, make that so we can see that a little bit better. We can go to graph and we can say y equals, you can use the parentheses or you can use the times symbol. So you can see our graph. We'll look at that down here in just a moment, but remember Control T will give us that. We could go up here, -2, so this is really ugly. So we would say 0.2 repeating, or I will tell you that this is 2/9. 0.6 repeating, that's 2/3. This is just 2. And then 3 to the first power is 3 times 2 is 6. 3 squared is 9 times 2 is 18. We haven't done exponent rules, so using the calculator will help you there. If we're going to graph this, I'm just going to kind of do what I did last time. Here's my x. Here's my y. I just want to make those a little bit darker so we can tell the difference. So -2 and 2/9, if I'm counting by ones, it's really tiny. And -1 and 2/3 is also still pretty tiny. 0, 2 is a little easier to see. 1 and 6, 1, 2, 3, 4, 5, 6. And then 2/18, I'm not going to be able to get to. And when I draw this, you can see that it is in fact going to be a curve. It's a fairly steep curve here. And you can also see that in our calculator. So when you do this, it's going to get really, really close to this x-axis, but it's not actually going to touch it. So our domain from left to right is going to still be all real numbers, but our range is going to be very, very close to 0, but we're not going to be touching it. So 0 is less than y, is less than, we could say -infinity, or we can just write it like this. We could flip it around and we can say y is greater than 0. Okay. Oh, I'm so sorry, that wasn't showing. There you go. What I'm going to ask you to do as you work through your practice today is, this is a growth and decay worksheet. I want you to realize that when B right here, if B is greater than 1, this is going to be a growth. If B is between 0 and 1, this is going to be what we call a decay. It's going to be decreasing. So this one, our B was 3, it was going up. In like manner, I could take in my calculator, let me get rid of my table here. If I added another one and I said T2 times, let's say, let's just use 1/2. So that is between 0 and 1 to the x power. So you're going to see that this one is decreasing. This is what we call a decay. It's going down. So on your practice today, I want you to first be able to decide, is it going to be a growth or a decay? And you're always going to be looking here. Now, they haven't written this very pretty for you. This is saying 1 plus 0.03. So our B value is 1.03. And that is going to show that it is, in fact, a growth. Your initial value, this is your A value, so you can see it right here, is, I don't know if it's money or not. I guess we'll just write it as 1,200. What is your rate of growth or decay? If it is a growth, then our rate of growth is here. Now, this is going to have to be, we need to write this as a percent. So if I'm at 0.3 and I want to make that a percent, this would be 30%. Okay. This one has a minus. So if I take 1 minus 0.02, then I get a B value of 0.98, which means this is a decay. Our initial value is still that A, 55. What is our rate of decay? This is how much is it going down. So 0.02, change it to a percent, is 2%. It's decaying by 2% every whatever. Okay, so I would like for you to try that. Now you can see after those first two, there's a couple that have the plus and the minus. You could even rewrite this as 1 plus 0.25 if you wanted to see what was going on. 1 minus something is 0.65. Well, 0.35, because this is going to be your decay. So I'd like you to try this. We will look at it when I get back. Do the best that you can, and I will see you later.